For my makeup lab video, I used orange dye against a blank of plain water in the same setup described in the YouTube video. I used orange against this blue light at 440 nanometers, and I prepared 3 different colored solutions against this blank. So we had 0 additive, 5 mLs, 10 mLs, and then 15 mLs. And then here we can see the math that I used. So we add a concentration of dye that is 0, that is the blank. We added more from there, so we added 5 mLs of dye, which made a 1.39% solution, on up to 10 mLs, which made a 2.74% solution, on up to 15 mLs, which made a 4.06% solution. Then I utilized the colorimeter app to shine through. I had to sort of stabilize my phone for this setup, but to shine through each sample to observe the blue light, and measured the blue and green values. Green here is not necessarily being measured in my later math, but I wanted to note it to make sure that I was doing things right, which makes sense. So my orange values, as the orange dye increased in concentration, the blue light values slowly decreased. They started out decreasing very slowly, and then by the 15 mLs, it was pretty obvious that the orange dye was absorbing a good bit of blue light. My G values proved that the orange was interacting with the blue, but again, they weren't particularly measured. Using the absorbance formula right here, meaning negative log of sample over blank value. Here's my data for absorbance. So we have the 5 mLs had very, very low absorbance, 0.0018. 10 mLs had 6 or 7 times that at 0.0094, and then the 15 mLs had to the power of 10 almost times that absorbance. So clearly the more dye, the more absorbance, which is consistent with what we'd expect. So the chart does look a little wild, but so my line of best fit is a little bit hard to predict, but it is consistent with what we'd expect. As the dye concentration increased, so did the absorbance of blue light, which is consistent. So that is all I have.